All right, I know exactly what happened. You were talking to your thesis advisor, and all of a sudden they yell out, "Whoa, that's a great idea. Let's do a meta analysis." And then you run off to your office all excited, but then you sit down, and all of a sudden you're like, "I don't know what meta analysis is. I'm not really confident with the research topic. What should I do next?" That's the purpose of this video. I have a bunch of tasks for you to help you establish some confidence with these things. And hopefully, in the end, you could start your meta-analysis on a good foot and hopefully produce a high-quality synthesis. Really, in the end, that's what we want. And so what I've devised is 3 major goals. And each of these goals has separate tasks, and hopefully if you complete these, you'll have a better understanding of your topic. I feel like sometimes we walk into a project and we don't conceptually quite understand what we're doing. And so this first collection of tasks is really to help you understand more thoroughly the concept you're going to attempt to synthesize. The more you know about the topic, what happens is the beneficial effect is you start to understand how feasible it becomes. And so really this part of the tasks is to help you assess whether or not the project is doable. On top of that, it's also to help you build up confidence in interest and commitment to the project, because you may not be super interested in the research topic that you were discussing with your advisor. And one way to increase that interest is to start reading studies on the topic. This will increase your commitment to the project, and hopefully you'll be able to sustain some sort of energy to help you complete the meta-analysis. The second task is stuff that will help you understand what meta-analysis is. And I totally get it. At this stage in your career, you've probably read a couple at this point or not, and you're trying to understand, like, what am I supposed to do? Like, what kind of project is this? And so these collection of tasks is going to help you with this deficiency in your understanding on how to complete the project. And the last collection of tasks, which I think were fairly straightforward, is to help you train yourself to see things in a more systematic way. I mean, with meta-analysis, you're going to be categorizing, classifying things discretely all the time. And so let's get started with that right away so that once you actually start processing studies for synthesis, you're ready. You're all fired up. So let's start with developing working knowledge on a topic. The first task I'm going to have you do, and this may seem a little silly, and a lot of these tasks are really super silly, but you may not know where to start, so I'm going to give you this job, which is to find 5 studies using Web of Science. Chances are you have access to Web of Science if you're at a research institution. There's 2 goals to this activity. One is to help you just get used to using this tool, developing keywords. Let me just say that we're not starting the meta-analysis yet, right? What I'm trying to do is expose you to some of the tools that you're going to use to complete one of these projects. And so the first task you're going to do is just find 5 primary literature studies. These are experiments. And you're going to collect these, PDFs of these, and put them on your desktop. The second task will be to repeat this process using Google Scholar. Google Scholar is an unusual place to find studies, mostly because you don't know what they're doing, and also because the Google is trying to figure out what you want, which is very different from Web of Science. Web of Science just flat out gives you everything it has based on your search term, whereas Google tries to be a little sneaky and smart about it and be like, "Oh, based on your previous search history, maybe this is what you're interested in." Nonetheless, it's a good start to try to find studies. And so you're going to find 5 studies using Web of Science, and then 3 using Google Scholar. The next task is you're going to try to find a study that is found within a dissertation. So we're going to search the open access theses and dissertation database, which is a nice place to start thinking about the gray literature, areas where projects haven't been published but still provide interesting information to a topic. On top of that, my guess is you're probably working on a thesis, and so it's not awful to get early exposure to like an actual thesis and see how it's structured. I feel like if you get exposed to that stuff, that also establishes some confidence about how to complete a thesis project. The fourth task I'm going to get you to do is you are going to try to seek out the fundamental, foundational paper on your research topic. So the first one that did this thing. And I've been really talking vaguely about topics here just because I want to keep the audience broad. But in my own little discipline, this could be something like the first study to apply this pesticide and found this effect, right? Chances are it's highly cited. It's been around for some time. Your goal is to find that thing. And it may not be easy to find. And so two ways to go about it if you're having trouble finding this paper is talk to your advisor, talk to your lab mates. Chances are they know what is the important paper to read in order to know the research topic. Then what you're going to do is you're going to print all these things out and you're going to read them. Why am I asking you to print these things out? Why is it important to have like an actual paper copy of this? This is a concrete thing you can hold in your hand that reminds you that you got things to do. Right? You're going to carry this around with you all over the place, and you're going to read it when you got time to read it. And I think that tactile reminder that you have something to do is really important for meta-analysis, because you're going to have a ton of these things to read and do, and if you could just like ground it with something, like just as simple as printing it out, I feel like is one way to actually facilitate the process. So you're going to read these things. And now the ancillary task here is I want you to enjoy these papers. The thing with meta-analysis is you read things with a totally different lens than you would typically as just like a scientist that's consuming research. When you're doing a meta-analysis, you're reading to pull out bits and pieces of information. And so this task, I want you to just kind of not do that. All I want you to do is read it and enjoy the science. That may seem like a weird thing to ask, but trust me, again, these are one of these things to kind of increase your commitment to the project and help you figure out whether or not you like it. Okay, and then finally, after doing all these tasks, I don't know how long this could take you. This probably could take you like a week or so to get done. What you're going to do is you're going to meet with your advisor, your thesis advisor. And after reading all these papers and all these meta-analyses, you're going to have two major things to discuss with them. One is whether the project is feasible. Now you have a fairly better understanding of the topic. You've read a bunch of literature on it already. You've read presumably important papers on the topic already. Now you need to sit down with your advisor and kind of gel that idea. This should be a casual meeting with your advisor. You should send them a couple of papers you think are cool for them to read beforehand, and just like chat about it. Try to refine the idea, refine the topic. Again, the idea is to assess whether or not the project is feasible. Better to figure this out now than before you start actually extracting data from studies. All right, now the totally different collection of tasks. These collections are meant to help you understand what meta-analysis is. So you have a good viewpoint of what kind of jobs you need to complete in order to polish the project so that it's nice, but also so that you don't stumble along the way because you did not know that you needed to do all XYZ to reach the next benchmark. So much like the first collection of tasks, what you're going to do is you're going to find 3 old meta-analyses. Now, the benefit of reading old meta-analyses is that they used to have to justify why they did a meta-analysis in the first place. Meta-analysis now is a fairly standard tool that everybody kind of uses, and so you don't get these nice little descriptions of like, I did a meta-analysis because it's better than doing a narrative review because I was able to account for sampling error, cross studies, etc. Right? You're not going to get exposed to these fundamental reasons why we do meta-analysis in the first place by reading new meta-analyses. Now, these meta-analyses should be at least 15 years old, and 2, should be on the periphery of your interests. And so, for example, if the idea you have for meta-analysis, the question you want to ask relates to plant-insect interactions, then read a bunch of meta-analyses that are about plant-insect interactions. Stuff that you're going to pay attention to when you're reading these things is how they approach questions, how they approach research questions, how they found studies, and how they quantified studies. That is by far, I feel like, conceptually the most difficult thing to start off a meta-analysis is like, what is the study outcomes of interest? Don't worry about that. We got tasks later on to deal with those things. The next task is to find 3 meta-analyses, 3 new ones. And the benefits of reading new ones is you get exposure to way more technically interesting analyses. The older studies tend to be very simple. Again, you're doing a new research project here, so you should be applying new tools. You should be applying like the more contemporary techniques rather than the old stuff. And so reading the newer studies, again, you learn the new tools. You also learn how people approach answering questions differently. And finally, you should totally make note of which tools were used to complete the projects, right? So what kind of software they use, what kind of statistical programs. Just kind of make note, put those things on your radar because chances are you will be using those things at some point. All right, well then we do this task number 9, which is print these out and read them and enjoy them, right? You're not reading these things at the technical level yet. You're reading these things just so that you understand what is a meta-analysis, what its purpose is, what the outcome of a research synthesis project is meant to be. And hopefully through this exposure, you're going to get a better idea of like, oh man, whether or not the project is feasible. Remember, we're always going to come back to whether or not the project is feasible. This is when you're going to meet up with your advisor again, and you're going to talk about meta-analyses in general. This is going to be a exercise on evaluating whether or not your advisor understands what a meta-analysis is, right? Maybe they haven't done one of these things, and they don't quite understand how much of a challenge it is to pull one of these things through. It's also a chance for you to talk about gaps in your training. And since you're starting this project off, you will have to learn a lot of stats along the way. And so ideally, if there are courses available at your institution, you should try to sign up for those things, or at least sign up for, these nice short summer courses. Anything to kind of help you understand what meta-analysis is. This is when you have your discussion with your advisor on what opportunities are available to help you with your project. This is also like another feasibility discussion, just because you've read a bunch of meta-analyses and you're like, I still do not know what I'm supposed to do. And hopefully through these tasks, you kind of have an idea what you need to do, but sometimes you're just like walking away like, this is way too complicated. I don't know what a mixed model is. Those are things you need to discuss with your advisor so that you could address those gaps. A lot to do. All right, task 11. Okay, I'm almost done. Task 11. I'm gonna teach you a really simple trick on how to evaluate information. It's used the PICO framework, which is used in evaluating clinical ideas, clinical questions, and we're going to apply it in a slightly different way. What it is it's a way to kind of like systematically evaluate, think about individual studies, which is something you're going to be doing over and over and over again with meta-analysis, but we're doing it now as an exercise so that you just kind of have a feel for what it takes to think about a study in that way, right? What I had you do before when you were reading papers for topics is I wanted you to enjoy those papers. Now I want you to revisit those papers with a totally different lens in how to categorize, classify the information contained within those studies. And we're going to use the PICO framework. And the PICO basically just has 4 things you need to categorize for each study. P for population. So let's just go back to this example I had with pesticides. What is the population being exposed to pesticides? Insects, fish. That's the population of interest. You're going to make note of that on your study. Second thing you're going to look at is, what is the intervention? Intervention is just kind of like a fancy medical term for treatment. So what was manipulated in the original study? Basically, in terms of the pesticide, can be the pesticide, or it could be that they're looking at factorial effects where they have pesticide exposure and parasites or elevated temperatures. Those are the treatments, the layers used to understand the pesticide and the effects on the population. So you're going to make note of that too, right? So in this case, pesticide would be pesticide X, right? Now, a really important part of experimentation is the manipulation part. And for that, you need a reference point. That's the control group. And so the third thing that you're going to try to pull out from each study is, what was that reference point? What was the control group? What was the baseline for comparison in the experimental manipulation? In the case going back with the pesticide, presumably be a group that was not exposed to pesticides, right? So you have a pesticide exposed group and an unmanipulated, unexposed group. That's what you're interested in pulling out now for each study. The last thing that you're going to pull out is the outcome. And this, by far, is the most important thing for you to know and understand when you're doing meta-analysis. The outcome, let me just bring it back to that pesticide example. I don't know why I picked that example. The pesticide example is like what was measured to provide evidence that the pesticide was having an effect, right? Were they measuring mortality or survivorship or growth in an insect? That's the outcome, right? So we already devised what the treatment and the control comparison is, but what was the measure of that? And so your goal will be to try to figure those out for your papers. Sometimes that's straightforward. If we go back to my YouTube meta-analysis course, Hard-Boiled Synthesis, the outcome was fairly straightforward. It was just looking at whether or not an insect was repelled when exposed to catnip as a repellent, All right, so that was the experimental outcome, which I needed to really develop a search image for pulling out in each study. And so by applying the PICO framework for each one of those studies you found early on, we'll train you to seek out systematically various bits of information in each study. And finally, bring it back. We're always going to meet up with the advisor, and you're going to talk about the feasibility of the project again. Now you've actually sat down and spent some time in a systematic way to figure out these studies. Is that something, was that a task that you could do quickly? Was it a task where you still didn't quite know what you were looking for? You need to discuss that with your advisor and figure out strategies on how to help you facilitate that process. This is where you have a conversation about what resources are available. Again, courses, books, online classes, whole bunch of other approaches to kind of help you get the tools you need before you start your meta-analysis. I think I covered everything I wanted to talk about. And the developing the systematic skills is really like one of these wonderful learning outcomes of actually doing a meta-analysis is you not only end up reading papers for enjoyment, for just consuming science, but also you now have like this a unique viewpoint on how to evaluate the quality and the experimental setup and whether or not the evidence presented is of high quality. All right, so with these 12 tasks, I know some of them sound a little silly, but maybe you needed to hear from someone that these are things you need to do to help you improve the feasibility in your mind, at least, on whether or not a meta-analysis is good for you to take on as a project. And if you do all these tasks, then I think you're kind of ready for more elaborate resources on how to do meta-analysis. Each discipline has their own handbook, right? So I'm in ecology evolution. This is the handbook that I use, that I hand out to my students after they've done all these tasks. And seek out that book. It's most definitely available in your library. Again, it's nice to have a tactile version of a book rather than just online only, digital only. You may migrate to a fully digitized research synthesis project. That's cool. That's not a problem. But nothing hurts to having some like concrete stuff in your hands to carry around and just read and mark up and make note of when you're just idling, right? There's going to be a lot of idle time in your project, mostly because some of these tasks are time-consuming and super boring. But hopefully, with these 12 tasks, I can set you up to do a meta-analysis. Good luck with that. I really wish I had more advice for you on how to do it other than these things. What I'd like you to do is just comment on the video and maybe say other things that kind of helped you before you started a research synthesis project. I've talked way too long already. This was only meant to be a 10-minute video. But, oh boy, okay. So I think I'm just going to wrap it up now. All right, summer starting, so hopefully your research synthesis projects are off to a good start, and I'll see you guys next time.